Hi guys, I'm Aditya and I work at Agility as a senior software developer. And in this video, I'll be walking you through two features which I built end to end for a fashion e-commerce platform's AI photo system. So it was an AI powered garment recolor tool and a background image search system. So I'll show you the exactly how this were engineered, including the decisions, the trade-offs, and the mistakes that shaped the final design. So yeah. So coming to the scope, the platform generates the AI product photos for apparel brands. So two features on it were mine and end-to-end. So the first, a user clicks on a garment inside a generated photo, picks a suppose picks a targeted color, and the garment recolors in new place. And the second was the keyword search across the platform's library of background and environment images. So a stylist can find the right background fast. I'll go through both, starting from recolor and yep. So in the recolor, the workflow goes like this. So when a user clicks a garment, let's suppose, the front end sends the click position as a fraction of the image plus the target color to an API route. So that route does one thing, it enqueues a job. So the actual image generation happens in separate worker service that pulls from a shared queue. Yeah. So that distinction matters for testing a lot, and running the app locally only exercises your code for that first request. So the generation itself run on whichever worker is deployed, not your branch. So the only way to test a service change end to end is to call it directly, and merging a change doesn't ship it until the worker is redeployed in it. Yep. So the fourth stage was pipeline, and the pipeline is the fourth step. First, it gets marked by the click. It draws a hollow ring around the point the user clicked on a copy of the photo. So never the original photo. And secondly, it identifies the user, the send the marked copy to a vision model and forces the response, into a structured JSON format. So I get back a clean item name. What else should change with it? What must not change? A natural language instruction instead of parsing prose. No, and thirdly, like it composes. So join those instruction and append a preservation block that protects everything else in the photo. The fourth step would be one single image edit call using that compose instruction plus the clean unmarked original. No, so the marked copy never touches the generation step. Yeah, and let's go to the slide. Yeah, uh, this is the model decision step. For the identity step, I ran a four model comparison against the fixed set of test photos. So two of those model got every single photos right. Like when accuracy ties, I don't default to the flashiest option, but I would rather pick the model that was faster and cheaper and match the rest of the code base which is already used. So that's the kind of decision that doesn't show up in a demo, but it's one that actually holds up in your production test. So let's go to the next slide. Yeah. Uh, so these are the few load-bearing rules which I followed. So a few rules here exist because something broke in the production first. So the ring is hollow, not a filled dot. Yeah. So because a solid dot covers the exact pixels, so the model needs to read, and that's fatal on the thin trim or lettering, for example. So the printed graphics and logos there are explicitly protected as of limits for recoloring, but printed lettering isn't grouped with them on purpose. So that is the reason if a word mark shares a color with collar trim, or say they are meant to shift in a single generation call. So because every additional edit re-renders the whole photo and compounds visual drift on the top of the last result. And every generation logs exactly what was identified and why. So if a result gets disputed, I can check the log instead of guessing whether the click even landed correctly or not. Yeah, let's go to the next slide. Yeah, so dead ends. Yeah, just as important as what we shipped is what thrown out, and why so nobody retries it. So segmentation based masking approach got removed completely here. It bled into skin and hair, and tuning the threshold never fixed it. So that is the reason a deterministic computer vision approach came in, which segments first, then do the color math, and kept breaking on trim, hardware, layered clothing, accessorize, you know. So those are exactly the cases where letting a language model reason in one sentence beats hard-coded geometry. A self-hosted segmentation model only found the right reason on two of the six test cases and took over half a minute per image on CPU. And higher resolution input images don't help it because the vision model normalizes to roughly the same segmentation resolution no matter what you feed it. So that's not where the accuracy lever is. Yeah. And that's yeah. So I want to be upfront about where this still falls short, you know. The low contrast colors like blue denim shifting to navy apply weakly because the actual pixel change is small to begin with. So my test library tops out well below production image sizes, and only the full resolution case has been spot checked so far. So that's the one data point, not systematic coverage. And structurally, there are now two sequential model calls in the user's latency path where there used to be one. So that's the real cost of the identify step, and it's on the list of the address. Let's go uh, to the query path. So the second feature is keyword search over the platform's background image library. So a query first expands through a synonym table, then it matches the against the full test search index where the image name counts more than its tags, and results gets ranked by relevance there. So if that search comes back with zero rows, and only then a typo tolerant fallback kicks in using trigram similarity. So it never blends in fuzzy matches alongside a working result set. So it only activates when the primary search truly founds nothing. And let's go to tuning the story slide. So that trigram threshold isn't a default; it's tuned. So it started at zero point 0.4 suppose, and at that level, searching for terminal for keyword terminal false match professional because they share a suffix, raising it to zero point 0.6 fix that, and real typos still pass through fine at that level. Separately, every new image gets uploaded, gets auto tagged in the background. A vision model reads it and returns a setting, tags, and a title. So that generate titles only fills in a blank. So if a real name was already given to that image, the automation never overwrites it. Yeah. Yeah. So talking about performance and discipline. So a search latency at scale is under 5 millisecond, and that's direct result of the index design, not a lucky number. So locally, it looked much worse, 2 to 3 second, and the instinct is to blame the query. So it wasn't the query, it was the network tunnel into the dev database. So I profiled it directly before touching a single line of my query code, and that's the habit worth keeping it. Verify whether the time is actually going before you optimize anything. Yeah. Second. Yeah. So traps across both the features. A few lessons cut across both features. Verifying a click actually land on the garment sounds obvious, but three test clicks landed on the studio backdrop and still passed because the model just named the most obvious garment in frame, and when it had nothing real to read. So now I sample the pixel and fail loudly on a backdrop hit, instead of trusting a plausible sounding answer. So I also built automated pixel level color checks, and all the three versions give false failures because rendered color naturally carries, shading part, and percent of foreground math fails apart on, small items like shoes. So the reliable check turned out to be looking at the actual image, and run-to-run consistency isn't the same as correctness either. So I had a photo score as one of the most consistent in the whole test set, while every run shared the exact same defect. So the last one I'll come to. Always import a shared validated prompt, and uh, never retype it, So a scratch script once claimed it reused a validated prompt, but had its own shortened copy with the key rules, So it quietly dropped, and that silently invalidated the entire comparison run before anyone noticed. Yeah. Okay. So that's the real build log, I would say, behind both the features, the architecture, the model decision, the dead ends, and the traps I'm not walking into twice. So yeah, thanks for watching the video.